All right. Third and potentially final video here, at least tonight. I'm going to get some rest, but um, we're starting with question. Actually, I'm going to start with 13. I know that I did not do a couple of these up here, but um, I know that there's going to be questions starting at question 13, so I'm going to skip ahead to that. I can answer the other ones in class at some point here. When it asks for which statement is not true, what you're what some people are still having problems with is just simply identifying the ratios. So I wanted to focus on this one. So let's look at tangent of L. So what we need to do is start by focusing on here's the angle I'm going to look at. Tangent of L is the opposite over adjacent, right? Tangent equals op over edge. Perfect. So in that case, the opposite side for L, again, for L it's 24. The adjacent, or the side next to, is 7. So that checks out. 24 over 7 is in fact the opposite of L, and the adjacent side next to it, 7. Cosine of L. Okay, so let me erase those. We have the cosine of L. They want to know, let's just find out what it is. Cosine of L is 7/25. See, L cosine is adjacent over hypotenuse. That's the definition of cosine. So when we look at L, the side next to the adjacent side is 7 over the hypotenuse 25. That does not match, so our answer is B. But let's keep going just for conversation's sake. Let's look at J. Hopefully C and D here will check out because it does just ask for which singular statement is not true. I'm hoping C and D are true then. So J, right here is J. Let me erase all the stuff I was working with. So there's J. Couldn't tell you what the angle is exactly, but I do know that the ratio of the sides for tangent for J would be tangent, again, that is opposite, 7, over adjacent 24, which checks out. We're good there. And now we look at J again, and we look at the sine. So sine is opposite. From J, the opposite side is 7, yes, and the hypotenuse 25. So just to be extra sure, we went ahead and looked through that. The biggest reason I want to go through this one, though, is questions 14, A and B. Let's be honest. I've had probably the most questions over these types of questions that I've had all unit. So here's how you go about doing this, you guys. So solving for x, the first thing we're going to do, we're going to set up, just like 13, I'm going to set up this ratio and the sine, the cosine, the tangent. I'm going to set it all up and then solve for the variable using algebra. So when I do that, let's go positive here. Let's go like a green color here. When I focus on 17, because I can look up in a table, or actually on your calculator, I can go to a calculator and type sine of 17 or cosine of 17. I can get the decimal approximation of the ratio of two sides. So I know 17 is already given, so I'm going to work with 17 degrees. Now, the two sides that I am looking to work with would be the side that is opposite of 17. So I've got op, and the hypotenuse of the triangle. So the trig function I'm going to use is the one that corresponds opposite and hypotenuse, which is sine. So sine of 17, this whole thing right here is just simply a number. It's the table value for 17 degrees along the columns, right? You go down the columns 10, 15, 16, 17 degrees. Now I'm going to go over to that second column on my chart, which is the opposite over hypotenuse. So I'm going to find a table value, whatever that number is, and that is going to be equal to the value of this particular triangle, the opposite over the hypotenuse. So let me, for the time being, erase that. So you're always going to set it up as sine, cosine, or tangent of an angle is equal to some ratio. Let's do the second one here. 58 degrees. I'm focused on 58. Let's go orange here. .58 degrees is my angle I'm working with. So here's, I'll call it out here, 58 degrees. The two sides with respect to 58 degrees that I'm working with here are my adjacent and the hypotenuse x. So for 58 degrees, I'm looking to work with the cosine column of 58 degrees, and I know that that ratio is always equal to the adjacent over the hypotenuse. So we've set them both up. Now there's a big difference between the part A question and part B question. Part A, it's really simple to get the answer. I'm going to multiply by 20 on both sides. Because if I take x over 20 times 20, I get x by itself. But if I take 20 on the right, I have to take the left side and multiply by 20. So now I get 20 sine 17. That, when I plug it into a calculator, let's do that. So 20 times sine 17. For this one, it's a very basic calculator. 20, I type that in, times, now I can't say sine and then 17. This one, I have to give the angle 17 and then go to the trig function and hit sine. Now I hit enter. The answer is 5.85. So that is the side length. Now let's check this out. My long side is 20. Look how small this angle is. That means that the side length is also going to be pretty small. Now with respect to 20, I would agree that 6 is about in proportion to that. So that checks out. This other one, you guys, this one's going to be the one that gives us some grief. So let me rewrite it in a way that I've got more room. So I need to get x by itself. Now there's a shortcut, but let's get the long way first, and then I'll kind of recap it in a really short way. I need to get x by itself, so I'm going to multiply both sides by x first. So I get x times cosine 58 equals 18. Because see, these x's would reduce, cancel each other, whatever. So now I can go do that, I don't know, change color. I need to get x by itself. I need to divide both sides by cosine 58. Right? Because then, if I do that, those cosine 58s cancel. I get x is equal to 18 over cosine of 58. Now, in my calculator, that comes out to 33, about 34. So let's check it. 58, that's a really big side here, but x, take a look at x. X is going to be pretty big because, I mean, this is 18 and it's on the smaller angle side. So x is going to be pretty big. So yeah, 34 makes sense. So to recap, the short version, when you have x, better change my color. Oh, something we haven't had for a while. If I say x, actually no, I can't do that either. Okay, hang on. If I said that the cosine of some number is 18 over x, the shortcut I was telling you about, it's very short. Rather than multiply this, divide that, just simply take and swap places with the x on the denominator and the sine, the cosine, the tangent, whatever it is, and you'll find that that works every time. Because look, my x, if I swap places, x is by itself equal to 18 divided by cosine of my angle. Well, that's all the work I did, and I still got the same thing. X is equal to 18 divided by cosine of 58. So there's your shortcut. Another long video, geez. Hopefully these are helping. I will see about making a couple more videos, but I hope this is enough to get you through some of the review topics. Maybe we can look at some real world application ones. I'm happy to do those. The difference simply is I'm not being given a picture of a triangle with some information and then solving it. I'm being given a story and say, hey, based on the story, draw the triangle. Once you draw the triangle, then solve the side needed. All right, so there you go. With that, that is the third and final video for tonight. I hope to be there tomorrow in class, but if not, this will help. Even if I am there, I'll still send you the videos if you would like. So thanks for watching.